today is Osmium, software I've been working on for about a year now. And first, the background, what's the problem that I'm trying to solve? Everybody knows, OpenStreetMap knows these kind of statistics. The amount of data is going through the roof. There's more and more data every day, and it's getting more and more complicated. And for years now, I've been writing software, and then there was more data, and I had to write new software, and software that would run faster and work with more and more software. And in the beginning, you could write an XSLT style sheet or a little script and work with OSM data that way. But nowadays, there's so much data that those ad hoc, simple methods often don't work anymore. And of course, there's the option of using Postgres, importing all your data into a Postgres database, and then Postgres can do all those great magic things for you in theory, but in practice you spend most of your time actually importing the data into Postgres and to optimize Postgres so that it's actually able to work with the amount of data that you have. So I didn't want to do that anymore, and decided I need something slimmer. I need a thin software that doesn't have as much overhead as Postgres has, as Ruby script has, or an XSLT script or something. And I needed something that's more modular. There's lots of software out there that works with OpenStreetMap data. OSM-to-PGS Go, for instance, is something that a lot of you might know. But it only does one thing. It does this one thing well, importing data that can then be used with Mapnik to render OpenStreetMap data. But it only does that one thing, and I needed a lot more things that I wanted to do. So it's something more modular, and something that doesn't need a lot of memory. A lot of the things, if you work with lots of OpenStreetMap data, essentially the whole planet, a lot of things get very slow the moment you hit the disk. But if you can do more processing in memory, it's faster, obviously. So something that would create as little memory overhead as possible. And this is one of those problems which is very hard to do in scripting languages, because every variable that you have, every piece of data that you store in a hash in Python or whatever it is, it's called a dictionary in Python, isn't it? Hash in Ruby or Perl or something, has a certain amount of overhead. And for Osmium, I went the other way. I'm using C++. C++, I know for every bit that I'm storing, I know what it is doing, where it's putting it. And this gives me a sort of low overhead, low memory overhead way. And also, if you work with lots of data, you want to work in a streaming fashion, so that you read the data in and you work on the data piece by piece, and you write it out in the end in some way. If you have to work on all the data at the same time, your memory or other resources are probably not going to be enough. This is not something you can do with every problem, but lots of problems can be solved in a streaming fashion. So Osmium is a reasonably fast, flexible C++ and JavaScript toolkit and framework for working with OSM data. It is not a finished application or something. It's a toolkit, it's a library, it's something that developers can use to build applications with. And there are a few applications already built with Osmium, and I'll talk about that. But the important part is it is a library that you can use to solve your specific problem. So a toolkit, it has a lot of classes, a lot of objects in the C++ code that do specific things you know from OSM. You have nodes, you have arrays, you have relations, you have tags, you have relation members. Those are the kind of things I have classes for that do those things. I also have an area tag, and an area class. Area is something that's not in OSM. There's no basic OSM object called an area object, but it's something that most people want to have in some way. You need to work with polygons and all of that, and I'll discuss that later. And you can do basic things on that. If you have a node, you can call the ID function, you get the ID of that node, or you can set it with the ID function. You can get the timestamp as a string. You can get from the node position, and then the longitude. From away, you get the list of nodes, and then this way you can get the first node, and then the reference, you get the ID. Those are the kind of functions that are sort of at the bottom of this library that you can work with and build other things on top. Then we have geometry objects, geometry classes for points, line strings, polygons, multipolygons, to work with the geometries created out of OpenStreetMap objects. So for instance, if you look at the C code here, you have a node, and from that node you can create a point geometry and in a constructor like this. And then you can write it out as WKT, well-known text format for those of you who know sort of classical GIS software that often works with WKT or WKB. You can write it out. You can create geos geometries or shape-lib geometries. Those are the things that can be used in other libraries for writing out shapefiles, for creating, doing more complex geometry operations. As you can create line strings, for instance here, this will create a line string object out of a Y, and that true means that it's reversing the geometry. So you get the line string the other way around from the Y. If you want to do that, you don't. As one of those options that you have. Osmium is also a framework in a sense that it gives you a lot of classes that help you structure your application. One of the architectures that you can use is you can define an OpenStreetMap file that you read in, and then you can define a handler that you write that handles the data that's coming in from that file, sends it on to an output, and it's written to another file. With this kind of architecture, you can implement converters, for instance, from a PDF file to an XML file or the other way around, or these kind of things, or some kind of filters that say, I'm only interested in this bounding box. So one application, for instance, that Peter worked on, he's reading the history, the OpenStreetMap data with the history, and cuts out bounding boxes from that and writes it out to an OSMFile. You would use this structure, and I'll show you a little bit later code so that you can see how easy it is to write something like this. There are a few cases where you want to have some kind of temporary storage, for instance, for the node locations, and I'll talk again about that later. So this temporary storage is something you'd typically have in memory to help you work with the data. Another similar architecture which you can use is for implementing some kind of exporters. You again read the data in some way, and then you have some export class to, for instance, export into shapefiles or into comma-separated values. That's the CSV export you can also use basically to create files that you can then import into Postgres if you want to do that. So for all these things that you see here, there's classes in Osmium that do these parts, and you can puzzle them together in the way that you want to. The OSMFile component in Osmium reads from files. It reads from standard in or reads from a URL with the help of the curl program. So you can, for instance, directly get data from the OpenStreetMap API that way. It writes out to a file or to standard out. It can read and write the XML format, compressed or uncompressed, or the PDF format. If you haven't looked at the PDF format yet, please do. It's a lot smaller than the XML. It's a lot faster to work with. So there's basically no drawback. The only thing you can't do is just open it up in a text editor or something, which you can't do anyway with a multi-gigabyte file. So, and it can read data with or without history. So the normal dumps don't have the complete OpenStreetMap history, all the changes, but every once in a while a complete full history dump is done, and Osmium can also work with that. Osmium can't read the change files yet, the OSSave files. That's something that's should be that we definitely want to have, but at the moment it doesn't do that yet. If somebody wants to help writing that part, you're welcome. So You initialize your application, and then you say, this is the file I want to read, and Osmium will read the file for you and gives you callbacks into your handler that you define up. And you can have those, you can define any or all of those callbacks here. So for it starts with the init callback, then you get a before nodes callback, and then for every node you get a callback into your code, and you can examine the node object and can decide what you want to do with it. And say, okay, are you interested in that node or not? And you can write it out or give it to an export handler or do something with it. And then it goes through all the nodes and goes through all the ways, then to all the relations, or that's how normally OpenStreetMap files are laid out. So it just parses does all the parsing and all that, and gives you a nice object that you can work with. And this is how this looks. So this is a complete handler here. You define a class myHandler that derives from the Osmium handler base class, which implements all the calls that you're not interested in as empty calls. And then in this case, all I do is I get the node object, and I say, okay, print me out the node ID and then the position. This is all this thing does, but this is a complete handler. Obviously, in your handler, you want to do something more clever, but it's not much more than this there you have to do. And this is the main program that you need to run this handler, and this is actually everything. So with those two slides, if you put those in the C file and compile it with Osmium, that already does something. You include the Osmium library. You have to initialize it once at the beginning of your program, and if you put a true in here, you get debugging output. Give it a true parameter. Then you say, I want InFile. It's called InFile. Initialized from the command line argument. Say, when you later start the program, you can give the OpenStreetMap file name as a command line argument. Then you initialize your handler that we have defined on the other slide, and you say, read my InFile, and here's the handler that should work on it. And Osmium does the rest. There's a few handlers that are already defined in Osmium that you can use out of the box. Some more than this, but those are the interesting ones probably that you can use as a model also for your own, or you can use them for some special thing. One is debug handler, which basically is similar to the node thing I gave you here. So it basically just dumps all the information that you can see that works. There's a statistics handler that adds up a few values, and more interesting are the CoordinatesForWays Handler and the Multipolygon Handler. And I'm going to talk about them now. The CoordinatesForWays Handler reads the position of all the nodes. So while the nodes are read from the file, it reads out the positions of each and every node and keeps them in memory. Or if you don't have enough memory, you can also keep them on disk. It's just a configuration option, basically. Keeps those positions, and then later on, once it has read all the nodes and all the ways in the input file, it can then create the geometries of the ways, because it gets all the nodes, gets all the position of all the nodes. It knows from its storage, and can build complete geometries of the ways. And to keep the data, there's a few options how to do that. The most important ones are mmap, which basically keeps one huge array where every node position is stored in there. You want to use that if you have a full planet file or a large excerpt. Or you can use a sparse table, which is a sparse table that's from a Google library that can store data in with very low overhead. And so if you have an extract of just Germany or Austria or some country or something, you would need that, and you don't need as much memory as for the mmap handler. Osmium also can assemble multipolygons. So from the relations that are tagged type multi-polygon or type border, and from the ways that are in those relations, it can assemble the multi-polygons. It handles nested multi-polygons, it handles touching in a ring, so if you have something like a forest, and inside the forest there's a clearing, and part of the clearing is actually a lake, it will do that correctly and create as many polygons or as many multi-polygons as are needed. It ignores wrong rows. A lot of the multi-polygons in OpenStreetMap, you're supposed to tag rows inner and outer, and lots of people don't understand how that works, and they're wrong. And it just ignores those and does the right thing. And it also fixes some broken geometries. For instance, if you have a polygon that's not completely closed, whereas there's a segment that's missing, it'll notice that and try to close it. That doesn't work in all cases, but it works in lots of cases. And another thing it can do is, if you have a multi-polygon and the border of the multi-polygon is crossing itself, it's a self-intersection at some point, in many cases it can fix that. There's typical errors that mappers do. And so it tries to be as clever as possible. If you don't want to have those broken things fixed, you can also give an option saying, "They don't fix anything for me," or just give me what's there. So this is how it does that. It has to read the file, the input file, twice for this to work. And the first time it reads the file, it ignores the nodes, ignores the ways, just looks at the relations. If it's a multi-polygon relation, it'll have a little bit in-memory storage where it keeps a list of all those relations and the ways that are needed for those multi-polygons. And then on the second pass, it reads the nodes, it keeps the node position. This is already done in the position, handler I talked about earlier that keeps the node positions, assembles the ways, and then for every way it looks up, is this way needed to build some multi-polygon? If yes, it's added to that multi-polygon. And once it has all the ways that are needed for a certain multi-polygon, it'll assemble it, fix the problems and all that, and then gives you another callback into your code. And then you can decide what you want to do with that multi-polygon, write it out in a specific format or do some other processing. It'll also give you callbacks at that point for all ways that are closed, but not part of a multi-polygon, because those are also areas, basically, or can be, depending on the tags, can also be areas. So it not only gives you the complex multi-polygons and with relations, but it basically gives you just a callback for every area that there is in OpenStreetMap, and you don't have to know in your code where that comes from, or you don't have to know anything about relations or all these things. Osmium is a header-only library. There is no .a or .so file or something that you have to link. You compile the whole thing every time. And the reason for that is there's lots of options. I've listed a few down here. Osmium with JavaScript, with GeoS, with Shapefile. You can say which parts you're interested in, and only those parts get compiled in to keep it as small as possible and to keep external dependencies low. Because if you look at all the list of if you look in the README, the list of dependencies that you have, it's quite large. There's lots of dependencies on external libraries, but all of those are only needed for specific cases. And if you're not interested in, for instance, writing shapefiles, you don't need to compile with shapelib, and then that's the dependency goes away. It compiles without warnings on GCC and LLVM. And there are even some unit tests, so although there's a lot more needed. I develop on Linux. It works fine on Linux. It does compile on Mac. I don't have a Mac myself. I just tried it on somebody else's computer. Nobody, as far as I know, is actually using it on a Mac. I had some problems there in the beginning, but now it should work on Mac, provided that you have the libraries. Nobody looked at Windows support yet, so I have no idea how much of it would work. It needs, for some things, it needs POSIX compatibility. So we'll see if somebody needs that. We'll look at those problems. There's a few example programs that come with Osmium that you can use to see and try out how it works, and then use it as a model for your own software. Osmium debug basically calls this debug handler I was talking about earlier. So you call Osmium debug with an OpenStreetMap file and gives you debug output about all the objects that are in there. Osmium can convert from PBF to XML and back, and compressed or not compressed, and these kind of things. Osmium 2Shape can creates two simple shape files from OpenStreetMap data, just as an example how to code that. There's a few more examples in the source. Here's another example that's also in the distribution. It's a bit hard to see node density. So basically, it's not interested in the weights, and the relation just reads all the nodes and creates this little graphic where you can see how the node density is in different geographic areas. So you see that's Europe and that's US, and there's more nodes there. It looks a bit like those NASA at night images of the Earth, with lots of lights in some areas and lots of darkness. That's Japan over there, and the rest of the world is pretty much without OpenStreetMap data, so it's still dark. Another program that uses Osmium as a backend is TagInfo. If you don't know what TagInfo is, come to my talk tomorrow. I'll talk more about that. TagInfo creates statistics from OpenStreetMap data. Hundreds of millions of data points that it has to add up. And it does that. It runs in under an hour on an 800 megahertz machine, needing only 3.5 gigabytes of data to create all these statistics. And it uses Osmium as a backend, and then has obviously the statistics counting stuff on top of that. This is what you can do. Before TagInfo, there was a program called TagWatch, or it still exists. It's written in Perl. It takes forever to create those statistics. It's really hard to run it for the whole planet. You need a huge machine to do that. And because Osmium is written in C++ and makes sure it doesn't store more than it has to and all that, we can do that you can do that much faster. There's more. This is all the C++ side I've been talking about now, but not everybody wants to program in C++, and obviously this is something some developers want to do, but users don't want to do. So I looked at some options how to make these things a bit more easy, and I found Google's V8 Javascript engine. That's the JavaScript engine that's inside the Chrome browser. And in Node.js, for instance, uses the same engine. It compiles JavaScript down to actually machine code, and so it's a real fast JavaScript implementation. It's open source, and you can embed it in C++ code. So optionally, if you want to, you can include a JavaScript handler in your Osmium code, which will then, the callbacks I was talking about earlier in your handler, that you will get into C++, you can also get into JavaScript code. So you write some JavaScript code, you get callbacks into that for every object, and then you can decide what you want to do with it. And you have access to those basic objects I was talking about. You have access to the exporter objects. So you can, for instance, do an export to a shapefile or something. There's a program called OSM.js that's part of Osmium, which includes already the JavaScript handler and the multi-polygon handler. And this is how you call it. It's a OSM.js -j. So it should read this objects.js JavaScript file, which contains some instruction what it's supposed to do with the planet file here. Or if you call it with -2, then it does this 2-pass thing that it needs for the multi-polygons. You say for the location store, this node position store, what option you should use, in this case an array, and the array implementation, and then again the JavaScript file with the instructions and the OpenStreetMap file. So those two things you can actually call, and the code in those JavaScript things are in there in the repository, and this will just do a few debugging outputs. But if you want to work with that, this is how the JavaScript code will look. Here's an example. I'm creating a shapefile, and I'm interested in the most popular street names, in this case in Germany. So what I do is I say, here, create me a shapefile. That's the name of the streets. It should have one field in it with a name, string field, 32 bytes long. And then for every way, I want a callback. If the way has a tag highway, if it has tag name, and the name matches Hauptbahnhofstraße, Dorfstraße, and a few others, then add it to the shapefile with this geometry and this name as a tag. And callback, I close the shapefile again. And this creates something that I can then load into QGIS, for instance, to show that. So these are the most popular street names, and all the streets of the 10 most popular street names in Germany. If you zoom in, it looks like this. Just a silly example of some of the things you can do. Because that's sometimes a bit too complicated already to write this kind of shapefile. To write this kind of JavaScript, there's a different way of doing that. A bit hard to see. A different way of defining the shapefile you're interested in. You say, okay, I need a road shapefile, type line, column name, and one way, this one is a string, this one is a bool. You define that once. You don't then have to write the callbacks yourself, but you just define a rule that says every way which has a tag highway, you want to put output into the roads layer. The name tag should end up in the name column in your shapefile, and the one-way tag, you do some more complicated things. So it sort of does the easy stuff. It does for you. If you just want to have this tag should end up in this column in your shapefile, it just does that for you. And if you want to do something more complicated, you can also do that. You can call a JavaScript function, which in this case looks at the one-way. If it's one yes true, the one-way goes into the right direction. It just writes it into shapefile. If it goes into the other direction, if it is tagged as -1, it turns the geometry around. This is what this does, and exports it into the shapefile. This is something you can't do, I guess, with any of the other shapefile exporters, because it's hard to do in a configuration file. This is why there isn't just a configuration file that you have to pass, but you get extra JavaScript. You can do the easy things easily, but the more complex things you can also do by writing custom JavaScript code. I mentioned that before a little bit. Osmium supports history data. The support is a bit minimal, but it's there, and there's more to come. Peter Körner has been working on that heavily. You can read and write history data. And Peter has been creating extracts using Osmium. And it needs, I asked him earlier, it needs 15 minutes to read the complete history dump with all of the history of OpenStreetMap and do 5 bounding box queries, and write 5 different bounding boxes out. So again, that's something that's pretty fast, reasonably fast to do. So I mentioned Peter. He has helped a lot. Frederick Graham, Christian Vetter have written part of Osmium code. I also like to thank the European Environment Agency, which paid for some of the work that I've been doing on Osmium. So if you're interested to help with writing Osmium, either yourself or give me a little bit of money to do some special things, or say you'll end up on this slide the next time I give the talk. So Osmium, it's free, it's reasonably fast for some things. It is flexible, that's the most important part. It is a library, it's a toolkit you can use to build lots of different things. It's for you. It's not finished. There's a lot of things. It is in production. Some GeoFabric customers have been using it for half a year, different parts of that. But it's not finished. I need your input. I need your ideas, what you want to do with that, and the problems that you have with the code, so that I know what other features are needed. And that's the end of my talk. Here are the links to the GitHub where all the code is. The API information, and of course the wiki. I try to document at least part of the I tried to document part of the Osmium stuff in the wiki, and there's reasonable amount of documentation in the code. It's might not be the easiest thing to get into because it does a lot of things, but it's worth it, I think. And now I have lots of time to answer all your questions. Thank you. Yeah, you have to wait for the microphone so the recording does work.
Hi, just a quick question. Does it export to PostGIS at the moment?
Does it export to PostGIS?
Yeah.
Not directly. There's no PostGIS driver in there or something at the moment. It's something I want to do, but just didn't have the time to do it. What it does is writes into CSV files.
Yeah.
And you can, with the copy command in PostGIS, you can read CSV files or files that basically, it's not comma separated, they're tab separated.
Yeah.
So it's not all there yet, but with a little bit of JavaScript, you can write out one of those files that you can then import with the copy command into PostGIS.
Yeah, from what you've said of it, it doesn't look too difficult to write your own importer, I would guess. One issue I have with OSM to Postgres is the amount of memory that it takes to import OSM data. So I'm wondering whether Osmium might be another option there.
Well, one of the reasons I wrote Osmium is because I was having a problem with Postgres. Postgres needs a lot of resources, so if you can work without Postgres, everything you can do before importing into Postgres is worth it. So I think for a lot of use cases, it makes sense to use Osmium with or without the JavaScript code to sort of pre-filter OpenStreetMap data in some way and only pick out those parts you are interested in, really, and then import those into Postgres. Okay, or into some other database and do some other more post-processing there.
Yeah, okay, thanks.
It's over there. Ta-da!
I would be interested, would it be difficult to make bindings to other languages? I guess Python is used a lot as well, for example.
Difficult to do bindings to other languages. Probably not. I'm not sure. I mean, it is standard C++ code, and I know Python is supposedly, I've never tried it, but supposedly it's very easy to include that.
I'm wondering about the data types, like polygons and stuff like that.
Yeah, you probably would have to write some. That's what I have to do with JavaScript. I have to write all those glue codes that, for instance, if you call from JavaScript and you want the timestamp or something, that it actually writes it out as a string or something that you can work in JavaScript with. And with the code for JavaScript for things like geometries. It doesn't, in many cases, you don't have access from JavaScript into all the details of the geometry, but you can get it as a string, or you can just handle the object and call methods on the object. But you don't actually want to look into the data normally. Normally, it's in many cases this is just a black box that you want to take from one place to another. You say, take this geometry, invite it out into that file. But you never actually look at the inside of the geometry in JavaScript. That would be too slow anyway, probably. If you want to do more complex geometry operation, you would do that in the C++ part. So it's not that many functions that you actually have to write the glue code for. It's just a few basic access things and then the connection to the exporter's input-output things.
Hi. Is the area callback you mentioned coming from Osmium, or is it from your own multi-polygon handler you included? Yeah, you said like everybody can include their own handlers in there.
Yeah.
And then after that you mentioned the area callback.
Yeah.
And is the callback coming now from the multi-polygon handler, or is it?
Okay, so what happens there is Osmium gives you this framework, this handler thing. It gives you callback into your code, but your code can then call the multi-polygon handler is one of the things it does. So normally, if you are interested in multi-polygons, you would write a little bit of code that says, oh, I've got a Y here. What do you do with the Y? Okay, first, I give it to the multi-polygon handler, because later on I need multi-polygons. And then I do this and that and this other thing with it. And you call into a few of the handlers that Osmium provides, or into the export facility or something. If you want to also export in your shapefile or something, you call in that code. And then later on, you get another callback, because the multi-polygon handler then does its magic and gives you another callback into your code with a completed area, and then again you can do your thing. Okay. Does that answer your question?
Yes.
Okay. Anybody else? All of the stuff I'm talking about is too complex that you can't have more questions, so there must be more. Or you've been all too tired after lunch break.
Is there the possibility of getting the JavaScript engine in Windows?
Java's the V8 in Windows. Does anybody know whether actually? Yeah, it must work. I mean, the Chrome browser, the Google Chrome browser, also works in Windows, so it must, in theory, work on Windows. And so that part probably would work. There are some other things where I need POSIX calls, for instance, for mmap and a few things, and those are probably more difficult in Windows, but I've never developed software in Windows, so I'm not sure. No Windows developers in the room can answer those questions. Okay.
We still have a few minutes.
Over there? To the right?
Right.
Is OSM Inspector a typical application using a framework like Osmium?
OSM Inspector predates Osmium. So yes, OSM Inspector, if I would write it today, I would use Osmium, and this is certainly one of the use cases that I had in mind. Because I wrote all the OSM Inspector stuff before I had Osmium, it uses other stuff, but for instance, the multi-polygon handler that is in Osmium was actually ripped out of the GeoFabric internal code that we had, which also generates the stuff for the OSM Inspector. So it's basically the same code, but it comes out of some other context. And this is something that I might at some point change and re-implement that using Osmium. Because this is exactly one of those cases where you have to do a lot of work with the OpenStreetMap data in some specialized way, and you don't want to import it all into Postgres. That was 2 years back or something. That was the first start with the OSM Inspector. I would import everything into Postgres and do some processing there, but it took forever. And some of the things still do that, because for some of the things it's nice to have a full-featured database that can do lots of clever things. But for many things you don't need it. And this is one example where you don't need a real full-featured database. You can do all those things, or most of those things in this streaming processing manner, and you don't need that many resources for it.
When I think about keep right, you would have to pass the whole planet file for every error check you do. Wouldn't that be redundant?
No, you can't. If you want to parse the whole planet file for every check, obviously that's not a good idea. But you parse it once, and then have some internal structure that gives the data to every check. I mean, you write a handler for every check that you have, and put them all together. That's something you would do in this case.
So you can have multiple handlers that don't interfere with each other?
Yes. You can have it. I mean, it calls into your code. How you organize your code is up to you. So you can have as many handlers there. You probably have one master handler, then hands it off to sub-handlers or something like that. And you can do all that in JavaScript if you want to.
Okay.
Okay, I'm interested also in, you mentioned that change file processing is something you're more or less planning to do. Do you have certain ideas already about that, or is that just, so do you have application uses you would like to use it for, or concepts how to realize that? So what could that be used for? Then, for example, would it just also provide callbacks for the change file contents, or would there be some plugins already for doing some pre-processing, like processing an existing OpenStreetMap file to include the changes, or what?
There basically there might be two different things you want to do. One is reasonably easy and would be to read a change file, apply the change file to an existing OSM file while it's reading it in, and then doing the rest of the processing. This is the first thing I'm interested in, because at the moment, whenever for instance, tag info has one osmosis job which runs every day to apply the changes of that day to the data file from last day, writes it out to disk, and then tag info, the tag specialized program is called, which uses Osmium then to do the statistics. So you have those two steps. And if I can read the change file in one step, and then write out the new file and then do the statistics in one step, that would obviously be a lot faster. So this is something I want to do hopefully pretty soon. I don't know how much time I have, but that's, and it fits quite easily into the architecture of Osmium. The other thing will be to read in the changes and give you callbacks that define those changes that you can then use to update some other kind of database that you have. And this is something I would need input from other people on whether they would need that and how it should look like. I'm not sure whether that's a good idea and how to implement that, because I tend to not use changes but always use the whole database. So many things are much easier if you have just one static database, one data file that you read through. It depends on what you're doing, and I'm interested in input there. If that's something that you would need, let's talk about that.
Okay, Jochen. We're a bit late.
Okay.
One last question.
One last question.
If it's short.
Very short.
Are frequent callbacks and restriction on using it very frequently in one piece of code?
Frequent callbacks?
Frequent callbacks.
Well, you get a billion callbacks because there's a billion nodes in OpenStreetMap. That's not the problem. I'm not sure I understand the question. Maybe you should take that offline. You can ask me afterwards. Thanks again.
So, Jochen, thanks for the nice info on Osmium. Thanks for your talk.